Welcome to the DIY Honda Garage channel. Welcome to this presentation on troubleshooting DTC P0110-17, which indicates a high voltage condition in the intake air temperature IAT sensor 1 circuit. This specific issue is crucial as it directly relates to the engine's performance and efficiency. The IAT sensor plays a vital role in gauging the temperature of the incoming air, a critical factor that the powertrain control module, PCM, uses to determine the appropriate air-fuel mixture for combustion. If the voltage from the IAT sensor exceeds a specified limit, it signals to the PCM that there is an abnormality, prompting this diagnostic trouble code to be stored. This can affect the vehicle's performance and emissions. During this troubleshooting guide, we will investigate the components involved, possible causes of this fault, symptoms that may be present, and detailed troubleshooting steps to identify the root cause of the issue. The IAT sensor 1 is vital in the vehicle's air intake system, located in the path of incoming air before it enters the engine. This sensor monitors the temperature of the intake air, which is essential for optimal engine performance. When the PCM receives data that the output voltage from this sensor exceeds 4.92 volts, it interprets this high voltage condition as a malfunction, leading to the storage of DTC P0110-17. The PCM relies on accurate readings from the IAT sensor to adjust fuel delivery. If the sensor fails or produces erratic readings, engine performance may suffer, resulting in a rough idle, increased emissions, or poor fuel economy. Understanding its precise location helps mechanics diagnose issues more effectively, ensuring that the vehicle operates smoothly. There are several potential causes for the high voltage condition of the IAT sensor circuit, as indicated by DTC P0110-17. Firstly, a defective IAT sensor itself could produce erroneous voltage readings. The integrity of the wiring that connects the IAT sensor to the PCM is crucial. An open or shorted wire can lead to incorrect signals being sent, which triggers this diagnostic code. An unstable electrical connection may also produce high voltage readings from the sensor when the vehicle is operating. Lastly, a malfunctioning PCM could misinterpret sensor data or provide improper voltage levels. Identifying which of these culprits is the primary cause is essential for proper repair and maintenance. When diagnosing the consequences of DTC P0110-17, several symptoms may manifest, suggesting a malfunction of the IAT sensor or its circuit. Notably, erratic engine performance could be observable, such as unpredictable idling or acceleration issues, rendering driving the vehicle more challenging. Increased fuel consumption might occur, since an abnormal reading from the IAT sensor can lead the PCM to deliver either too much or too little fuel to the engine. Additionally, the illumination of the check engine light serves as a visual indicator that the vehicle's onboard diagnostic system has detected a fault in the emissions or performance system. Noticing these symptoms early can prevent further engine complications. The first step in troubleshooting DTC P0110-17 involves initiating the onboard diagnostic system. Begin by turning the vehicle's ignition to the on mode without starting the engine. This action provides power to the vehicle's electronic systems, including the diagnostic test mode function. Then, using the Honda Diagnostic System HDS tool, check the voltage readings from the IAT sensor. Specifically, you need to monitor the IAT sensor 1 voltage value. If this value exceeds 4.92 volts, it confirms the existence of a malfunction. At this point, you will be able to further test the sensor and its connections to determine the specific cause of the high voltage issue. Next, you will inspect the MAF sensor IAT sensor 1 connector, which has 4 pins. First, ensure that this connector is securely connected. If disconnected, errors may appear. For further testing, disconnect the MAF sensor IAT sensor connector completely. After that, jump the terminals number 2 and number 4 of the connector using a jumper wire. With the jumper in place, turn the vehicle to the on mode again and observe the HDS readout for the IAT sensor 1 voltage. If the system indicates a voltage below 4.92 volts under this test condition, it reveals a fault with the MAF IAT sensor. If the voltage reading remains elevated, then the issue may lie within the wiring or the PCM itself, leading to further diagnostic action. In this step, you will perform a thorough inspection of the circuits associated with the IAT and MAF sensor. First, ensure that the MAF sensor IAT sensor 1 connector is disconnected, along with the PCM connector B. This step is vital for accurately inspecting the integrity of the circuits. After disconnecting these connectors, check the ITA1, TA, open wire values and the SG2 open wire inspection values. Under ideal circumstances, both should indicate less than 1 ohm. If either reading deviates from this value, it indicates a wiring fault, either an open circuit or a short circuit condition in the harness. Identifying these defects is crucial to ensuring that proper voltage is reached at the sensor, allowing it to function as intended. The final troubleshooting step involves inspecting the powertrain control module, PCM. This step should only be pursued if previous inspections of the IAT sensor and wiring have shown normal conditions. The PCM is responsible for interpreting all the inputs from various sensors, including the IAT sensor. If the earlier tests indicate that the IAT sensor and circuit are functioning correctly, yet the DTC persists, the PCM is likely faulty. Testing the PCM requires special diagnostic tools to evaluate its performance against the expected parameters. A malfunctioning PCM may not correctly read sensor data, leading to erroneous fault codes being generated. This step is crucial in confirming whether the PCM needs replacement. After conducting the necessary repairs based on previous diagnostic findings, it is essential to perform a verification process. Start by clearing the DTC from the PCM using the Honda Diagnostic System HDS tool. After clearing the code, retest the vehicle by taking it for a drive under normal operating conditions. Monitor the IAT sensor readings closely. They should fall within the normal range of below 4.92 volts during operation. If the IAT sensor operates correctly without triggering the DTC again, you can be confident that the issue has been resolved. Always ensure that all connecting components are reattached properly and that any changes made to the electrical systems or PCM settings are documented for future reference. To prevent the recurrence of DTC P0110-17 related issues in the future, implementing a routine maintenance strategy is advisable. Regular inspection of the IAT and MAF sensors is key. Checking for physical damage, corroded connections, or loose wiring can deter potential faults. It is equally important to perform periodic checks on wiring harness integrity, ensuring that all electrical connections are clean, secure, and free of any signs of wear or corrosion. Scheduling regular diagnostic assessments can help catch minor issues before they escalate into significant problems, harming engine performance. By maintaining a proactive approach to vehicle maintenance, the longevity and efficiency of the engine management system can be greatly improved. In conclusion, DTC P0110-17 is a diagnostic code that reflects a high voltage condition in the intake air temperature sensor circuit, significantly impacting engine performance. Understanding the role of the IAT sensor is crucial for anyone involved in diagnosing or repairing modern Honda vehicles. Adequate troubleshooting involves a series of systematic steps, from verifying sensor function to inspecting wiring, and if necessary, examining the PCM. By thoroughly following these steps and implementing preventive maintenance strategies, you can ensure that the vehicle operates efficiently. Staying vigilant about these components will not only enhance performance, but also contribute to the overall longevity of the vehicle's engine management system. Please like and subscribe to the channel. See you next time.